Your circuit breaker keeps tripping. You reset it, and 10 minutes later it goes again. Here's the part most people get wrong. A breaker that trips is not broken. It is doing its job. It is telling you something specific, and there are only 6 things it can be telling you. By the end of this video, you will know which one it is and exactly what to do about it. First, 30 seconds on what a breaker actually does, because the rest of this only makes sense if you understand this one thing. Every circuit in your home is a loop. Power leaves your panel through the hot wire, travels to your outlets and lights, and returns through the neutral wire. Wires can only carry so much current before they get hot. A 15 amp circuit uses 14 gauge wire. A 20 amp circuit uses 12 gauge. If more current flows than that wire can handle, the wire overheats. An overheated wire inside your walls is how house fires start. The breaker is the thing standing between that current and a fire. When it senses a problem, it opens the circuit and cuts the power. So when your breaker trips, it is not failing, it is protecting you. And what you never do is replace it with a bigger one. Putting a 20 amp breaker on 14 gauge wire does not fix the problem. It removes the protection and leaves the problem. Now, the 6 causes, because number 1, and by far the most common, is a simple overload. An overload means you are asking one circuit to deliver more current than it is rated for. Add up what is plugged in. A space heater pulls about 12.5 amps on its own. A hairdryer, 10 to 12. A microwave, 10 to 12. A vacuum, 8 to 12. Put a space heater and a microwave on the same 15 amp circuit, and you are already over. Here is how an overload behaves, and this is your first clue. It does not trip instantly. It trips after a few seconds or a few minutes, once the current has been high for long enough. And it almost always happens when you turn something on, or when a heating element or a motor kicks in. The fix is the easiest one on this list. Move some of that load to a different circuit. Not a different outlet in the same room, because that outlet is very likely on the same circuit. A different circuit, ideally a different room on a different breaker. Because number 2 is a short circuit. A short circuit is when the hot wire touches the neutral wire directly. When that happens, current does not go through your lamp or your appliance. It takes a shortcut straight back, and the current spikes enormously in a fraction of a second. Here is the clue. A short circuit trips the breaker instantly, not after a minute. The moment you flip it on, it goes. And there are often physical signs: a burning smell, a scorch mark or discoloration around an outlet or switch, a buzzing or crackling sound. This one you do not troubleshoot yourself beyond identifying it. A short circuit means damaged wiring or a damaged device, and it is a genuine fire risk. Leave that breaker off and call a licensed electrician, because number 3 is a ground fault. A ground fault is when the hot wire touches something grounded: the metal box, a metal appliance case, a wet surface, or a person. Instead of returning through the neutral, current escapes through that path. This is the one that can electrocute you, which is why bathrooms, kitchens, garages, basements, and outdoor outlets are required to have ground fault protection. That is what a GFCI is. It watches the current going out and the current coming back, and if even a small amount goes missing, it cuts power in milliseconds. The clue for a ground fault is location and moisture. It happens in wet areas. It happens after rain, or when an outdoor outlet gets water in it. And often it is the GFCI outlet itself that trips, not the breaker in your panel. If a GFCI keeps tripping in a wet area, dry everything out completely, unplug what is on that circuit, and press the reset button. If it will not hold with nothing plugged in, you have a wiring problem, and that is an electrician. Because number 4 is an arc fault. An arc fault is a spark jumping across damaged wiring. A staple driven too tight, a nail through a cable, a chewed wire, or a loose connection in a device. Arcs generate serious heat, and they are one of the leading causes of electrical fires in homes. Arc fault breakers, called AFCIs, are designed to detect that specific pattern and shut the circuit down. Modern bedroom and living area circuits are required to have them. Here is what confuses people. AFCI breakers sometimes trip on things that are not actually dangerous. Certain vacuum motors, some older power tools, and some LED dimmers can produce electrical noise that looks like an arc. So an AFC trip is not automatically an emergency, but it is also not something to ignore. Because number 5 is a faulty appliance. Sometimes the wiring is perfect and one device has failed. A motor with worn insulation, a heating element that has broken down internally, a frayed cord. This is the easiest one to prove, and here is the exact process. Unplug everything on that circuit, everything. Then reset the breaker. If it trips immediately with nothing plugged in, stop. The problem is the wiring or the breaker, and you need an electrician. If it holds, plug your devices back in one at a time and wait a minute or two between each one. The device that trips it is your culprit. Take that one out of service. Because number 6 is the breaker itself. Breakers are mechanical, they wear out. A breaker that has tripped hundreds of times over many years can weaken to the point where it trips at loads well below its rating. It becomes what electricians call a nuisance tripper, signs of a failing breaker. It feels warm or hot to the touch. It makes a buzzing sound. It will not stay reset even with the circuit completely empty. Or it trips at loads it handled fine for years. Replacing a breaker means working inside a panel where the main lugs stay energized, even with the main switch off. This is one of the genuinely dangerous jobs in a house. Call an electrician for this one. So let us put it together into one diagnostic sequence you can actually follow. Step 1. Note what was running when it tripped. Write it down. That single detail solves most cases. Step 2. Unplug everything on that circuit. Step 3. Reset the breaker properly. Push it all the way to the off position first, until you feel it click, then back to on. Most people only push it halfway and think it failed. Step 4. If it trips immediately with nothing plugged in, stop. That is a wiring fault or a bad breaker. Electrician. Step 5. If it holds, add devices back one at a time, a minute or two apart, until it trips. That device or that combination is your answer. Step 6. If it only trips when several things run together, you had an overload. Redistribute the load. Now, the part that matters most. When do you stop and call someone? Call a licensed electrician if you smell burning. If there are scorch marks or discoloration. If the breaker is hot or buzzing. If it trips instantly with nothing plugged in. If it will not reset at all. Or if it keeps tripping and you cannot find a cause. And never do these 3 things. Never replace a breaker with a higher amperage one. Never tape or wedge a breaker to hold it closed. And never ignore repeated tripping, because a breaker that keeps tripping is telling you about a problem that has not gone away. Quick recap. Trips after a delay, when several things are running, that is an overload. Trips instantly with a burning smell, that is a short circuit. Trips in a wet area or the GFCI button pops, that is a ground fault. Trips on an AFCI breaker in a bedroom or living area, that is an arc fault or electrical noise from a specific device. Trips when one particular device is connected, that device has failed. Trips with nothing connected at all or the breaker is hot, that is the breaker or the wiring. 6 causes. 1 diagnostic sequence. And a clear line for when to hand it to a professional. If this helped, the next video breaks down every breaker in your panel and what each one actually protects. That is on your screen now. Thanks for watching.